Hello. For problem statement 1, the time-dependent one-dimensional heat conduction through the thickness of a rocket motor casing. The inner surface of the casing is exposed to hot combustion gases, while the outer surface is exposed to ambient air at 300 Kelvin. To run the simulation, the user must provide inputs for the time step, to the simulation time, special step, and initial hot temperature caused by the gas combustion. The importance of this study is to prevent a catastrophic failure if the material chosen was not suitable. Secondly, to understand the thermal stress and fatigue of the material. Third, to help selecting the best material with suitable thermal properties. For this example, we will be using the explicit method to solve. It is because it is to calculate and program, sufficient accuracy for some practical engineering applications, and stability and convergence depends on spatial and time step sizes governed by the dimensional stability parameter, which required less or equals to 0.5 for accuracy. Now, this is the derivation of the mathematical solution using the explicit method. This is the programming part for solving the explicit method. Based on the program shown before, the user needs to input the number of spatial intervals, number of time steps, hot temperature from the combustion engine, and the total simulation time. The outcome that is expected is for the result table to come out explaining about the intervals, positions, temperature, and the approximation error across the casing of the rocket. Next, the result will also show the graph involving the temperature distribution across the casing of the rocket between the cause interval and the find interval. This is the input, and this is the graph. As you can see, that the line is pretty much similar between the cause grid and the find grid, showing it is convergence. And here we can see that the approximation error is very low, showing that it is reliable and the program works. Now, for the analysis, based on the results we achieved, the accuracy of the explicit method depends on the time step size. It is better if it's small, good for first order in time. Efficiency of using this method are low computational cost per time step because they only involve direct calculation. Number 3, the convergence if provided the dimensional stability parameter is below 0.5, satisfying for stability. Next, effect of step size causes various outcomes. It may be unstable if it is too large. Lastly, the programming difficulty is easy to implement. Next is the advantages. The explicit method is very simple to understand and implement. The update formula directly calculates new values from previous ones, making it easy to code. Economical cost per step is each step involves only direct calculations. No need for metric system to solve, unlike implicit methods that could be hard to program. Lastly, the limitations. The conditional stability and convergence depends on the dimensional stability parameter, which are needed to be lower or equals to 0.5. If dimensional stability parameter exceeds 0.5, the result produced might oscillate and diverge from the real solution. This method also will struggle with stiff problems and requires small time steps to solve them. As a summary, I contributed to solve the Parabolic PDE engineering related problem involving temperature distribution of casing of a rocket. I learned on how to use MATLAB to run simulations and go into the difficulty of programming the codes. Furthermore, I acquired further understanding on engineering applications involving Parabolic PDE using the explicit method, hence finding its limitations and advantages. That's all from me. Thank you.